So I've had to make these x because this is our unknown, and it has been explained to me by you people why the x is the same for both of them, because they left at the same time. The point that was missed because I wasn't recording because I'm an idiot is the fact that if they had left at different times, we would have to add or subtract that time from one of the plane's times. Yes. Right? Now, what is the rate at which the plane Montreal to Calgary is flying? 550 kmh. Yes? And what about the Calgary to Montreal? 450 kmh. Yes? Yes. And what distance are they traveling? 550 times x and 450 times x. Yes? Yeah. Because distance always equals rate times time. Right? Now, we know something else about this distance, don't we? How far are the planes traveling? 3,000 kilometers, yes? Yeah. Which means plane 1's distance plus plane 2's distance has to equal what? 3,000. So you guys have your chart. Now you have to think about, what do I know? The plane's distances must equal 3,000, yes? Why? Well, that's how far apart they are, right? Yeah. Leighton and I are 5 steps apart. If I take 3 steps to Leighton, he takes 2 steps towards me, will we meet? Yeah. Yes. How far will we have traveled? We'll have used up a fraction of the 3,000, yes? Yeah. Of the 5 steps, I mean. Leighton took 2, I took 3. Right? Yeah. So we know that distance 1 plus distance 2 has to equal 3,000, don't we? But we also know that distance 1 equals something else. What else does distance 1 equal? It also equals 550 x. And what does distance 2 also equal? 450 x. Has to equal 3,000, yes? Now, if distance 1 plus distance 2, so what goes here? So what do we get? 1,000 x equals 3,000. So what does x equal? 3. So how long were the planes traveling? 3 hours. Just like the boat that Gilligan was on. A 3-hour tour. Have any of you ever seen the Gilligan's Island show? No. It's brilliant. Do any of you have any questions about motion problems? I like motion problems. I find them to be the easiest. Why? 1 second, Sam. Why do you think I find motion questions the easiest of them all? What about it? Taylor. There's a formula, isn't there? Yeah. It's always distance equals rate times time. Always. Right? Most of the other ones, you got to come up with your own formula. Now, the problem with distance equals rate times time is the problem you guys, a lot of kids have with it, is you don't like this step. You don't want that unknown there, do you? That bothers you. And it's not because you're, not ready to do math or anything. It just bugs you because you want that to be a real answer, don't you? You want there to be a distance there. So that's where the thinking has to happen. Right? Okay. So, I would like to maybe do one more of these. You guys should have do you have a bit of space? Before we get into rate of work? I want to try one more. I want to try one that's a different kind of motion problem. I just got to find it. So why don't you start on number 13 on the sheet I gave you? 13, 14, 15, 16, 17, 18? Yeah? And that will give you practice in leaving your variables in your distances. Do you understand what I'm saying? The thing that bugs you. Just do up to 18 while I try and find that other question that I wanted to do. Because I've got it somewhere on my computer. But as you guys are well aware, my computer... All right, so we've got a request to look at 24, the very first one. No problem at all. What have we got? We have cruise ship, and we have a boat. Those boats are traveling a distance, a rate, and a time. Yeah? Oh, I haven't turned it on yet because I'm an idiot. Right, Sam? Yeah. Cool so far? Okay, what do we know? The rate of the cruise ship is 20 kilometers an hour. 20. The rate of the private boat is 25. Right? Okay. What don't I know? After how long did the private boat overtake the cruise ship? So I don't know the time. Who left first? So cruise ship has been on the high seas for X amount of time. The private boat has been on the seas for X minus 1 because they left an hour later. Yes? Right? Yeah. Now, when did they overtake? That's when they caught up to each other, right? Yeah. So that means their distances would be what? They'd be the same, wouldn't they? So this guy's distance is 20x, and this guy's distance is 25x minus 1. And when their distances are the same, 20x must equal 25x minus 1. Now I solve it. 20x, 25x minus 25, right? Minus 5x equals minus 25. X equals 5. So about how long, after how long did the private boat overtake the cruise ship? No. The private boat is X minus 1. So it was in 4 hours when the boat left, 5 hours from when the cruise ship left. Depends on who's asking, right? If I'm out suntanning on the deck of the cruise ship, that little boat's going to go by me 5 hours after we left. If I'm chasing down the cruise ship in the little boat to be a pirate and steal all their stuff, I'm going to get there 4 hours after we left. Got it? I don't know what the answer in the back says. 5. Okay. Oh, because when you read it, after how long did the private boat overtake the cruise ship? So you're counting from the cruise ship's perspective, right? So I'm on the cruise ship. I'm in my deck chair. La, la, la. Oh, I've been on this boat for 5 hours. Oh, good. There goes a boat. Okay? Not that I've ever been on a cruise ship because I think they would be boring.
I've been on it.
That's just me.
I want to do Alaska.
My wife likes cruises. I think I would be bored. I also don't like the amount of waste on a cruise ship.
I saw whales.
Good.
What do you mean waste?
Garbage. Cruise ships have 5,000 people on them. All right. Everybody good? Okay, I will pause. Okay, we got 2 cars. So we got car 1, car 2. They leave at 4:30. One car goes 75 kilometers an hour. So I've got a distance, a rate, and a time. Car 1 is going 75. Car 2 is going 85. What's the distance? And what's the time? Do I know the time?
No.
No, so what is it?
75 times X.
X and X, because they left at the same time, right?
Yeah.
Okay, so what's the distance? 75X and 85X. But there's something else. What else do I know about the distance?
This is equals
Car 1 plus car 2 has to equal what? 600 has to equal car 1's distance plus car 2's distance, yes?
Yes.
Well, what is car 1's distance? 75x plus what is car 2's distance? 85x. And what does that have to equal? 600. 75 and 85 is what? 160x has to equal 600. So what does x equal? 3.75. So my time is 3.75 hours. Now that's the question. How long until they were that far apart? Now, what time of day is it? It's 16:30 plus 3:45. So 16:30 plus 3 is 19:30 plus 45 is 20:15, which is what time? Subtract 12. 8:15. Any questions? So where were you stuck, Sam? Because you're usually a rock star. What's bugging
I
you?
got the whole table and then the whole right too, and then I just didn't know what to do after that.
Okay. That's where the math comes in,
I
right?
understood that there were 600 numbers apart,
Yep.
but then I didn't think that I didn't break down the car 1 plus car 2 with 600.
I see. Okay. Everybody else was okay there? All right. Mr. Yes, Carlin? Huh? I don't actually know. Let's assume it is. Oh, no, it's not. It'll be 1 hour ahead in Winnipeg. So if it's noon in Edmonton, it's 1 p.m. in Winnipeg. I think. Just let me double check. I got a chart of...
Yeah, Winnipeg's 1 hour ahead.
I think it is. Yes, Winnipeg is 1 hour ahead. Are we ready to talk about number 26? No problem. I'm just going to write the chart. So that should be the chart, yeah?
Yeah.
So what do I do with that? 80x plus 90x has to equal 1360, yeah? 170x has to equal 1360. What does x equal? 8, right? So the time was 8 hours, yeah?
Yeah.
So they left Winnipeg at 8 a.m. Winnipeg time. So what time did they meet? 8 hours later, which is 1600, which is 4 o'clock Winnipeg time. Or 1600. Everybody Gouda. Now, C is a very important question there. Why? You've checked the answer on the back. What's that mean? No. When you did all this work, you assumed what? What is the assumption you made? You guys have been in cars. What happens? Traffic. What else? Pit stops. I don't know about you guys, but 8 hours straight in a vehicle, I gotta pee. Right? So, yeah, that's what I'm saying. That's why the question is there. You've made an assumption. The assumption is that friend one got in the car and went straight to 80 kilometers an hour and stayed there. Meaning apparently he drove out of his driveway onto the highway and zoom. Apparently he was living on the on-ramp. Now, are we okay to make those assumptions in math class? Why? Well, we're working on a method, aren't we, Sam? Right? We're not putting the probe on Pluto. Yeah? As you go further along, you've got to take things like that into account. All right?
Yeah.
And then you got the plane and the car leaving the garage, and then you guys should be done. Is everybody okay with them?
Yeah.
You're generally figuring them out?
I'm gonna do number
Yep.
first.
Okay. What was next? The plane. Deplane, boss. Deplane. Plane 1. Plane 2. Distance. Rate. Time. Plane 1 leaves Vancouver and flies at 600 kmh. Plane 2, 15 minutes later, flies at 700. How long was plane 1 in the air? Leaves Vancouver for LA. X. How long was plane 2 in the air? Plus? X minus 0.25, right? Okay. What else do I need? When they catch up, the distances are what? They're equal, right? So what's this guy's distance? What's this guy's distance?
600 times x minus 2.25.
No, just,
And then it'll be 600x equals.
right? And then 600x has to equal 700x minus 0.25. 600x has to equal 700x minus 350 cut in half, 175, right? Right? Okay, so negative 100x equals negative 175. X equals 175 divided by 100. 1.75, yes? 1.75 hours. Right? What time is that?
It'll be 8:30, so 1.75 is 9,
10:30 minus 15 minutes. 10:15 a.m.
Wait, is it 1.75 an hour and 45?
Uh-huh.
And then if it left at 8:30, we're gonna be like 10:15.
So exactly what I wrote?
Yeah, no, but 10:15 minus.
The question says, at what time, how long did it take the second plane to overtake the first one?
Okay, yeah.
Right?
I thought it was minus 15.
So, no. Sam makes a valid point. Right? What is different about this question than the cruise ship question? Our point of view is different, isn't it? Because we're talking about when will the second plane catch up. So what is it really? 1.5. Right? What time will that happen? It is still 10:15 though. Right? Because why? This part is going to be 1.5 hours till this, because we're talking about the second plane now, right?
Yeah.
Sam has flown to LA and Babette is in love with him. Babette needs to catch him, so Babette gets on the next plane to LA.
I have a friend named Babette.
Do you really?
Yeah, he's a guy.
Yeah, but in French, Babette is this. And it's a girl's name.
Oh, Babette. I don't think it's
Mr. Anderson.
Couldn't you just call the one plane and say that the left leg is missing?
No. All right, we all good? All right. And we've got about 7 minutes left, which is just about enough time to do the last one. Yeah? We got car 1, and we got the police. We got a distance, we got a rate, we got a time. How fast is car 1 going? 100. How fast is the police going? 120. How long was the car driving? X. How long was the cop driving?
X minus
0.25. When do they catch up? When the car's distance, when C1's distance equals the police distance. Well, the C1 distance is 100x. The police distance is 120, x minus 0.25. 100x equals 120x minus 30. So minus 20x equals minus 30. X equals what? 1.5 hours. Now, whose perspective are we looking at? How long did it take the cruiser to catch up with the car? So what time do I want? Car time or cruiser time? Cruiser time. So X is 1.5, so where does it go?
To there.
Right there, right?
Yeah.
So 1.5 minus 0.25 minus 0.25 is 1.25 hours.
Yeah.
Do we care about what time it happened? No, we just care that it took an hour and 15 minutes to catch him. Is everybody Gouda gravy?
Yes.
Great.
Okay, all that will be on YouTube later.